Study Session 7. Vision 3. Transduction, sensory limits, dark and light, adaptation. Introduction. In this lecture, we shall discuss the concept of transduction, sensory limits, dark and light, adaptation. The mechanisms underlying these concepts are also examined. The concept of accommodation, retina projection, and the visual pathway also form parts of the discussion. Objectives. At the end of this lecture, you should be able to 1. Explain the concept of transduction, sensory limits, and adaptation. 2. Demonstrate the understanding of light and dark adaptation. And 3. Differentiate between transduction and adaptation of light. Pre-test. Define transduction. 2. Briefly explain sensory limits. 3. How does the eye adapt to light and dark environments? Content. Transduction. Energy from stimuli cannot go directly to the brain. Light, sound, and other kinds of energy from the outside world are not able to travel through the nerves, and the brain cannot understand what they mean. To be useful to the brain, sensory messages must be translated into neural impulses that the neurons carry and brain understands. The translation of one form of energy into another is called transduction. Sense organs transduce sensory energy into neural energy. This is accomplished in the sense organ by the sensory receptor cells. As stated earlier, sensory receptor cells are specialized neurons that are excited by specific kinds of sensory energy and give off neural impulses from their axons. Some sensory receptor cells are sensitive to sound, some to light, some to chemicals, and so on. But in every case, the receptor cells give off coded neural impulses that carry the transduced sensory messages to one of the sensory areas of the brain. The sense organs themselves, such as the hair, eye, nose, and so on, are constructed in special ways that expose the receptor cells to sensory energy and help them transduce it into neural impulses. At the center of every sense organ are receptor cells that do the transducing. Sensory limits. Even when we have receptor cells that can transduce a kind of sensory message, not every message will be strong enough to be detected. The term threshold refers to the lower limits of sensory experience. The primary kinds of threshold are the smallest magnitude of a stimulus that can be detected and the smallest difference between two stimuli that can be detected. The absolute threshold is the smallest magnitude of the stimulus that can be detected. Measuring such threshold is not a simple matter. People differ considerably in their sensitivity to weak stimuli, and the sensitivity of each of us differs from time to time. For this reason, absolute thresholds are defined as the magnitude of a stimulus that subjects can detect half a time. The smaller difference between two stimuli that can be detected half the time is called the difference threshold. For example, the smallest change in intensity of your stereo that you can distinguish as louder 50% of time is your difference threshold for that stimulus. Detailed knowledge of absolute and difference thresholds has, in fact, been used by the electronics industry to design better stereo systems. Dark and light adaptation. When you walk into dark movie theater from the daylight, you are blind at first. Your eyes can pick a very little visual information. On spending about 5 minutes, however, your vision is in the darkened room considerable improves slowly. Take two. Considerably improves slowly until you can see fairly well. When you exit the theater from the matinee performance, take two. Matinee performance, you have the opposite experience. At first, the intense light blinds you. You squint and block out the painful light, but in a little while, you can see normally again. What in fact is going on? How can you be sighted one moment and blind the next moment just because the intensity of light has suddenly changed? The phenomena are called dark adaptation and light adaptation. Here is what happens in the retina during dark adaptation. In a lighted room, the rods and cones are being used frequently, so they are not very sensitive. When we enter darkness, the rods and cones are not sensitive enough to be stimulated by the low intensity light. This gives the receptors a rest, so they begin to gain a sensitivity by making a fresh supply of the chemicals used in light reception, which have been literally bleached out by the intense light. At first, both the rods and the cone are covering their sensitivity, so improvement is fairly rapid. But the cones become field sensitive. Remember, they are not very sensitive in weak light. Within about 5 minutes, so the rate of improvement slows after that. The rods continue to improve in sensitivity slowly, reaching a level of sensitivity to light that is an amazing 100,000 times greater than the bright illumination after about 30 minutes in the dark. In light adaptation, the eye is much like a human camera. The lens focuses a visual image on the retina of the eye, which contains two kinds of sensory receptor cells, the rods and the cones. The wavelengths, amplitude, and complexity of the light waves are transduced into neural messages. These two kinds of receptor cells perform their jobs somewhat differently. Cone work best in intense light, provide good visual acuity, and transduce information about color. Rods work well in weak light, do not provide good acuity, and do not code information about color. The eye does not function well when the intensity of light suddenly changes, but it quickly regains its sensitivity through the processes of light and dark adaptation. There are two major theoretical explanations of how the visual systems transduces color. One states that three different kinds of cones are most sensitive to light of different wavelengths. The other suggests that two kinds of color processing mechanisms in the visual system process complementary colors. Each theory is correct at different stages of the information process about the wavelength of light. Summary. In this study lecture, we have learned that the concept of transduction, we noted that energy from stimuli must be translated into neural impulses that the neurons carry and the brain understands. This is accomplished in the sense organ by the sensory receptor cells. Sensory limits in the term threshold are also learned. Cultural orientations in terms of group ideology, individualism, and collectivism shape the behavior of people in social setting. An individualistic culture considers the interest of individuals to be above the group interests, while the collectivist culture emphasizes that the group's interest takes priority over individuals' interests. This is the end of study section 7. Thanks for listening.